Welcome to our foundation channel from class 8th, chapter 10, direct and inverse variation. Right? So let us see the topics in this chapter. First, let me explain the variations. So what are the types in this? We have the two types, direct variation and inverse variation. So these two types with the examples I'll explain one by one. Next, using unitary method. So in this only I'll show even arrow method. So the shortcut technique to find out the unitary method concept. Using the arrow method, different problems I'll explain in this. And same chapter, let me continue even time and work problems also in this. Right? Based on the time and work, the word problems I will come. How to solve the shortcut techniques and briefly let me explain everything in this. First, let us see the variations, right? So in this we have two type of variations, direct and inverse variation. So when you see this direct variation, briefly let me explain first. So direct and inverse. If you see these two concepts, generally two quantities are said to be in variation if change in one quantity causes corresponding change in the other quantity. So let us take two quantities like cost and number of articles. Like for example, if you take the pen, so one pen cost is rupees 10. Then if you take for two pens, it must be 20 rupees. So one change in one quantities. So number of pens is increased, then even cost is also increased, right? Two quantities must be said to be variation if change in one quantity, that is causes corresponding change in the other quantity also. So if one quantity is increased, if other quantity also increase, that is come under direct variation. And inverse variation is opposite. So one quantity is increased, other quantity must be decreased. Like for example, work done by some people, let us take, and number of work and men. Let us say for example, 7 men can do one work in 10 days. Let us say, else 7 men can do work in 10 days. If we take only one man, 7 members can do work in 10 days. So this is when person is reduced, then work should be number of days to do this work is must be more. It will take around 70 days. 7 men can do work in 10 days. So only one person can do in 70 days. So one quantity is reduced, other quantity is increasing. So this is a type of change. So one will be increase and other must be decreased. Like more is in speed. For example, inverse means if you take the speed of the car, then it will take less time. Speed and time if you compare. If you go more speed, you'll reach the destination less time. Okay, if you go 30 kilometers per hour, in case if you take 1 hour, then if you take the speed 60 kilometers per hour, then in half an hour only you'll reach, right? Speed is increased, so time is reduced. So these type of come under inverse when both quantities are increasing at the same rate, like one quantity is increased, other quantity also must be increased. If one quantity is decreased, then other quantity also decreased. That is come under direct variation, right? Let me show briefly this. Direct and inverse variation with examples I'll explain briefly. So when you see this definition again, two quantities are said to be in direct variation if the increase in one quantity, right, causes increase in other quantity. Same way the decrease in one quantity causes the decrease in other quantity. And inverse variation is two quantities are said to be inversely if any increase in one quantity causes a decrease in other quantity, just opposite. Or else decrease in one quantity increase the second quantity. Here is one is increased, right, speed, so this time is decreased, right? So these are the main definitions. Let us start the problems, how the questions will come from direct and inverse. Based on the question, how to identify which is belongs to direct and inverse, and unitary method, time and work, all the problems you'll see now. Direct variation. So let us see the concepts very clearly with examples in this topic now. So as we discussed, one quantity is increased, other quantity also must be increased. One is decreasing, other is decreasing. So these come under direct variation. So let us take if x and y, let us take x and y are in direct proportion or in direct proportion or direct variation. If these two are in direct variation or in direct proportion, then x divided by y is constant, is a constant. Right? Let us see one example. Uh, as we checked pens and cost. Pen is one quantity and their cost is a second quantity. Here is one pen cost is rupees 10, then two pens cost is rupees 20, and three pens cost is rupees 30, so on, right? Value will increase. Here is x divided by y. Now this is the x quantity and it is y. X divided by y is constant always. So 1 by 10 is exactly equals to 2 by 20. You can cancel, right? 2 ones are 2 10. So 1 by 10. And 3 by 30. 1 by 10. Same. So 1 by 10, 1 by 10. All the quantities will be equal. So x divided by y is equals to constant. It not does not change. Same it is every time. Right? So based on this, we can conclude that if x1, x2, x3, so on are some different values of y1, y2, y3, so no, so x1 by y1 is equals to x2 by y2 is equal to x3 by y3 is same it is. Let us see the example questions based on this. 15 meters cloth. Take one example. 15 meters of cloth cost rupees 1940. Right. Question is, find how many meters of cloth of the same kind can be bought for rupees 4,000, 4,656. So how many meters? Let x meters of cloth cost is 4,656. So how many meters of cloth will get for 4,656? If you see the two quantities, one is the cloth and one is the cost, right? Cloth and cost. And cloth is first one is 15 meters, right? And second item is x meters. For 15 meters cost is 1940 and for x meters cost is 4656. You just make the table this type, then we can find out. Right, here is the according to the direct proportion, first quantity divided by second quantity is in same ratio, same constant. Since if the case of direct variation, 15 by 1940 is equals to x divided by 4656, because both are in direct to proportion. So you can take x divided by y is a constant always. Right. You can simplify this. From this you can go for cross multiplication. X is equals to 15 by 1940 times, this is dividing, no, multiply 4656. Okay. This you can simplify, you'll get 36 meters. Calculation I'm not showing, just calculate, you'll get 36 meters. 2 table, 5 table, you can cancel this. So therefore 36 meters of cloth can be bought for 4656. Right. If you can make like this table, easy. First one divided by second quantity is equal to this first one divided by second. Any number we can make this in easy way. Right. So this is about the direct variation. Let us see some questions for the inverse variation also. Inverse variation. So we discussed the topic already. Two quantities, let us say x and y. Two quantities, x and y, are said to be in inverse variation if an increase in x causes corresponding decrease in y. If the increase in x quantity, then y quantity must be decreased. Again, if it is decreasing in this, y quantity must be increased. So it's reverse. Decrease in y, and decrease in x causes corresponding decrease in y. So if x and y are in inverse proportion, right? So let us take an example and I'll show the method. And men, number of days to complete the work. Let us take these two examples. Yeah, in example, two quantities. Men and number of days to complete work. Let's take to complete work. Number of days they'll take to complete work. For example, 8 members, 8 men can do the work in 4 days. Let's take 8 men can do the work in 4 days. Instead of 8 men, if I take only 4 men, 8 members they do work in 4 days. Within 4 days they complete the work. But only 4 members I sent. So they must take double the days, right? So 8 should be. Right. Only 4 member. 8 members can do 4 days. And if it's 4 member, there must be 8 days. Okay, instead of 4, if I take only 2 members, how many days they'll take? Let us see. 4 persons only 8 days they'll do. Only 2 members if I send double this. So 16 days they'll take. Right. This is the method. So when one quantity is increasing, other quantity is decreased. Now 8 to 4 is decreased. Then 4 to 8 is increased. Same way. 4 to 2 decreased and 8 to 16 is increased. And if you notice this both, let us say this is the quantity x and second one is y. 8 into 4, 4 into 8, 2 into 16, you're getting same number. X into y. Here if you observe from this both examples, 8 and 4. 8 into 4 exactly equals to 4 into 8 is equals to 2 into 16. First quantity and second quantity if you multiply, getting same number. 8 4 is a 32. Same 32. 16 2 is a 32, right? So x into y is equals to constant. In this first quantity and second quantity, the product is constant always for inverse variation. Right. Let us see the example now. Remember, first one into second quantities always remain same. Now, if for example, if the only one man, how many days they can do it? In case if x days. So first one into second one. That means it should be equals to again 1 into x. That is equal to x. Must be 32. So 32 days they'll take only one person. Right. Let us see with other example. Let me take the question. If 78 men can do a work, can do work in 140 days. In 140 days, 78 men can do the work. Right. In how many days? How many days? Let x days. In how many days will 42 men can do the work? Is the question. In how many days? I'm taking as x days. So 42 men can do the work in x days. This is about inverse variation because from the question we need to understand this direct or inverse. If one quantity is decreased, other quantity is increasing here. Men is reduced. So surely number of days will take more to do the work, right? So is inverse variation. So if you make the table, number of men and number of days. Number of men and number of days. Let us see this. First one, second one. Here is number of men, 78 men. They're taking 140 days. And 42 men is, let be x days. Always first one is quantity. This is x and y quantity. No? So x into y is constant in this. X into y is equals to constant. So because of since it's inverse, it is inverse case, inverse variation. So therefore 78 inverse, no. So xy is equals to constant. First one into second quantity if you multiply should be equal. Therefore 78 into 140 is exactly equals to 42 into x. Right. This is from this statement you can find out x value. Then x is equals to 78 into 140 by 42. 42 is multiplying take this side divide. Yes, this is simplify, you'll get 260. So 140, that means 42 men can do the work in 260 days. Okay, this is number of days, right? 42 men will do the same work in 260 days. So simple thing, whenever the question is based on inverse variation, when quantity is reduced, this is increased, right? And this must be decreased. 78 to 140 is increased here. So men, okay, same ratio you can take, constant. Men here is 78 to 42 is decreased. So this must be increased. Just observe the quantities and you can make this. So this is about the inverse variation. Based on these two, let me explain clearly about the using unitary method and arrow method in this. Using unitary method, so direct and inverse variations. So together we can see the problems in this unitary method. I'll explain some arrow techniques like arrow method also to solve the problems. Let us see the question wise. In this first one, a fort had provision for 300 men for 90 days. So provision is sufficient for 300 men for 90 days it is. After 20 days, 50 men left the fort. So how long would the food last at the same rate? So after 20 days, 50 men left. 300 men for 90 days is sufficient, right? So after 20 days also, even is after 20 days. That means for remaining 70 days. Let's start the problem from after 20 days. So the statement is given, sufficient food is for 300 men for 90 days. So therefore, after 20 days. After 20 days means again for 300 men the provision will last for 70 days because 20 days are over. After 20 days then for 300 men the provision will last 90 minus 20, that is because 20 days are over, so remaining 70 days. That means after 20 days for food is sufficient for 300 men for 70 days now. Right, now we have to find out 50 men left the fort. 50 men left. That means for one man. So after 20 days, for one man, provision will last. That is 300 into 70 days. For this many days is sufficient for one man. Right? But after 20 days, 50 men left. Right? So from 300 minus 50. 300 minus 50, no, that is equals to 250. Now for 250 men, we have to calculate. Therefore, for 250 men, because for one man, the provision is sufficient for 300 into 70 days. Now for 250 men, the provision will last for 300 into 70. Divide by how many men? 250. Because for one person, 300 into 70 days. 3 sevens are 21. 3 zeros to 21,000 days. For 250 men means this number divided by 250. This you can calculate, you'll get the answer. So 0, 0, 5, 5 0, 5, 6. Again 5 times 1, 4. 14 into 6, 84. So 84 days. 84 days is sufficient. So 300 men for 90 days is sufficient. But after 20 days, this is the case. After 20 days, for food is sufficient for 70 days. So for one man, 300 into 70. For 250 men, right? That number divided by 250 will take. Right? Is the question. And one more. Let us see this type. Another type of question. Two men or three women can do a piece of work in 45 days. Either this or this. Two cases. Two men or three women can do the work in 45 days. Find in how many days will 6 men and 1 woman be able to complete the same work. combination. So if you notice the problem, according to the amount of work done in the same time, 2 men is equal to 3 women. So in that is 2 men capability is exactly equals to 3 women. You write this statement. So 2 men capacity capable is exactly equal to 3 women. Then 1 man, 2 men capacities for 3 women. Then 1 man is 3/2 women. Okay, 1 man capacity exactly equals to 3/2 women, right? And we have to calculate for 6 men, right? So slowly you can take to the 6 men. And for 6 men, 1 man equal to 3/2 of women, right? So 6 men means 3/2 into 6 women. And that is equals to 9. 3, 2 ones are 2. So 9 women. That means 6 men capability is exactly equals to 9 women, right? Now 6 men and 1 woman. That means 6 men plus 1 woman is exactly equals to, if you observe, actually 6 men is capability is exactly 9 women, no? So instead of 6 men, I'm taking 9 women plus here is 1 woman. So 9 plus 1, so 10 women. And that means 6 men and 1 woman capability is exactly equals to 10 women, right? This is a line. Since 3 women can do work in 45 days. 2 men or 3 women? This one. 3 women can do the work in 45 days. Or 2 men can do work in 45 days. But as per the statement, 3 women can do the work in 45 days. Therefore, here is 10 women how many days? Right. So 3 women can do work in 45 days. From this, we supposed to calculate for 10 women, because 10 women is exactly equal to 6 men and 1 woman. Then 10 women is how much? Let be x days. So here is one thing, when the people is increasing, number of days will be reduced. So it's inverse proportion. Inverse proportion means you can go for the multiplication. First one, inversely proportion. So first one into first one, second one into second. First one is the x and let be y, right? X into y is a constant. So 3 into 45 is exactly equals to 10 into x. From this, x is equal to 3 into 45 by 10. So we can cancel this. 5 table 9, 2. And this is 9 3s are 27 by 2. So 13 and a half. 13 and a half days. That means 6 men and 1 woman can complete the work, same work in 13 and a half days. Right? This is a statement you can take. Instead of women and men, convert into the one person according to the given data we can make, right? Okay, this is the way we can solve. Let me show you some problems based on this arrow method. Okay, so here is the question. This question I'll explain arrow method. Problem is here. 8 men can dig a field in 14 days, right? Working 6 hours a day. In how many days can 7 men dig the same field working 8 hours a day together? So 14. Let us take together now. So here is two cases, 2 units you can take. 8 men, 14 days, 6 hours per day. Three cases. So observe this. 8 men, 14 days, 6 hours per day. In how many days? So days you have to calculate. Number of men, hours per day, and number of days. Taking the statement, arrow method will show. It's easy. Number of men and hours per day number of days. How many days we have to calculate? Now what you have to calculate, make it to the last line, last column. Remember, right? Here is a 8 men, 6 hours per day. It will take 14 days. Second line, how many days? How many days? No, let be x days. Can 7 men, same field, working 8 hours per day. 8 hours. So after writing like this, actually what you have to calculate, remember, make into the last line, last column. And other two you can take here. Now last one you can take to the down arrow. Last one you can just represent to the down arrow, top to down. Next, according to this, we'll take this both. For example, number of men and number of days you observe, what type of variation it is, and hours per day to number of days you check. So if this is a direct variation, same side arrow you can keep. Inverse variation, opposite will keep. Right? Now, for example, first one, number of men, number of days. So if it is a more men, they'll take less days, right? And less men, more days. That means number of men and number of days is inverse variation. Because of inverse variation, you can take the arrow reverse. Actually, starting last one, top to down, you took already. Now, according to this, you change. First one and last one must be inverse. So this is down I took, no? So this must be arrow take up. Again, second to this one. What you have to calculate, that one you compare both. Now, hours per day, number of days. For example, 6 hours per day. They are working 14 days. If you take more hours per day, they'll take less days. Just inverse variation, observe. More hours if you spend per day, within less days only you'll complete. Less hours per day if you work, it will take more days. Inverse variation, this also. So since this was inverse variation, you take reverse because first and third comparing. Now after this is the arrows we arrange, right? Now which arrow head is on head side, you can take the number up. Now this is x is here and 14. Arrow is down now towards x. Take x by 14 is equals to what you have to calculate, number of days 14x, arrow is down, x divided by 14. Next is equals to product of these both remaining, that is always which arrow head is there, that should be number on top. 8 and 7, 8 by 7, arrow head is on for 6, so 6 by 8. Simple. I'll repeat, just number of this you have to calculate, right? So x is to the arrow side, x must be on top, other number is down, is equals to product of these both. These both means which arrow is there, that should be on top. 8 by 7, 6 by 7, keep the multiply. You can calculate, you'll get x value. 8, 8 cancel now. X is equals to 6 by 7, 14 is dividing, multiply. 7 times 2 is a 14, 12. So this is 12 days. So 7 men. So can dig the same field working 8 hours per day in 12 days, right? Just arrows you can make in this pattern. According that you can calculate this value. Right? This is the way. Next we'll see some problems based on this time and work also in this. Time and work problems. So in this direct and inverse variation, let us see the concept of this event time and work problems. Before starting, let me show you these three important formulas or points. For example, first one, with example I'll show here. If a man can do a piece of work in 12 days, okay, person, if he can do one piece of work in 12 days, so in one day he can do 1 by 12th part, right? For example, this is the total work. Now a person can clean this ground, for example, in 4 days. If you can clean this entire ground in 4 days, so one day you can do only 1/4 part, right? This much is for one day, total is 4 days. So this is first day, that is 1 by 4. So just means reciprocal. In one day he can do reciprocal of this number, how many days he can able to do. So 1 by 4th part of the entire total work, right? That means 1 day's work is nothing but 1 by number of days required to complete the work. So 1 day's work is 1 day's work in this example is 1 divided by number of days to complete work is 4. So 1 by 4. Okay, 12 days no is 1 day work is 1 by 12. So 1 day's work is 1 by number of days required to complete the work. This is the first one. Next, same way, first one is opposite will take. Like if a man's 1 day work is 1 by 15, then he can complete the work in 15 days. Reciprocal of this 1 by 15 is 1 day's capacity. So he can complete in 15 days, 15 by 1. That means number of days required to do a certain work. Number of days. 1 by 1 day's work. 1 divided by 1 day how much you can able to do. Right? This one will get. Next, third one. Number of days required to complete a certain work. Number of days to complete certain work is one more option is work to be completed by 1 day's work. Work to be completed. How much work to be completed by 1 day's work. This also. What is the balance work? Divided by 1 day's work capacity to required to complete a certain work. Okay, so these three statements we'll use in these problems. See one by one. Here is the question. A can do a piece of work in 80 days and B in 100 days. Right? That means A's 1 day work. So he can do in 80 days. So 1 day work is 1 by 80. And B. So B is 1 day work. So according to this, B in 100 days. So B 1 day work is equals to 1 by 100. First line. Now they work together for 20 days. Together they work for 20 days. First of all, together in 1 day how much they can do it? That means A plus B's 1 day work. So A can do 1 by 80 at part of the work. B will do 1 by 100. So 1 by 80 plus 1 by 100. This is the A and B's 1 day work. 1 by 80 plus 1 by 100. 400 is LCM. Right. 5 plus 4. 9 by 400 part of the work it can do together in 1 day. Right. Next one. Now they work together for 20 days. So A plus B's 20 days work. Because 1 day they can work 9 by 400 for 20 days. 9 by 400 into 20. 21s are 20, 20s are 400. So 9 by 20. 9 by 20th part of the work they can do in 20 days. Okay, so they work together for 20 days. Then B goes away. Then B went off. In how many days will A finish the remaining work? So first of all, you have to find out the remaining work. So according to this, remaining work is total work is always 1 minus A and B together 20 days they work and completed 9 by 20. So 1 minus 9 by 20. That is 20 minus 9 by 20. Yeah, 11 by 20 is the remaining work. Now account the problem. Number of days taken by A to finish the remaining work. So number of days taken by A to complete remaining work. So to do remaining work. According to this, very fast. So number of days taken by A to do remaining work. The according to this is remaining work by A's 1 day capacity. Here you see now. Number of days required to complete the certain work, whatever work to be completed by 1 day's capacity. So here is remaining work. So whose balance capacity you have to find out? A, right? So we need to know the remaining work first. Remaining work by and A 1 day capacity, that is A's 1 day work, 1 day how much he can able to do based on that. So in this problem, remaining work is 11 by 20 by A 1 day capacity is 1 by 80. 1 by 80. This you can calculate. 11 by 20. 1 by 80 reciprocal 80 by 1. 20 times 4 so 44 days. In case B leave after 20 days, A is supposed to do 44 days more to do the remaining work. Okay, so these are the statements you remember to simplify. Any question, if you asked find out how many days particular person can do, so that the balance work by is 1 day's capacity. You can find the days, right? Now let us see another type in this similar. Most of the question you expect same, calculating 1 day and all together, right? So in this problem, A can do 2 by 3 of the certain work in 12 days, right? And B can do 1 by 6 of the same work in 4 days. Find how many days will they together complete the work. So since A's 12 days work capacity is given, so A's 12 days work. 12 days work is equals to 2 by 3, right? That means A 1 day work we can find out. So A's 1 day. 1 day how much he can do? 12 days he can do 2/3. So 1 day. So that means is 12 days work divided by this number of days, right? So that means 2 by 3 and divide by 12. That's why into 12 you can take. 2 by 3 into 1 by 12. That is all divided by 12. This you simplify. 2 ones are 2 6. So 1 by 18 is 1 day's work means total work by in 12 days he can do 2/3. So in 1 day 2/3 divided by 12, that is 1 by 18. Same way B. This is B. Let's is given B is B can do 1 by 6 of the same work in 4 days. So B is 4 days work. 4 days work is equal to 1 by 6. Therefore B is 1 day. 1 day work is this 1 by 6 divided by, actually this is 4. That means you can write 1 by 6 into 4. That is 1 by 24. 4 means 4 by 1, no, reciprocal. So 1 by 6 into 4 by 1. 4 by 1, no, 1 by 4. Right? That is 1 by 24. Right? So we got A's 1 day capacity, B's 1 day's capacity. So A can do 1 day 1 by 18th. B can do in 1 day 1 by 24th. Now how many days will they together complete the work? Let us do together in 1 day how much they can do. So A plus B's 1 day work. 1 day work is 1 by 18 plus 1 by 24. This is simplified. 72 is LCM. 4 plus 3. 7 by 72. 7 by 72 is the 1 day's work. Then A and B together can complete in reciprocal of this. So this means AB 1 day work is this. Therefore A and B together can complete in, so that means 1 day they can do 7 by 72. So that is in together they can do 1 by 7 by 72. That is 72 by 7 is reciprocal. 10 2 by 7 days. Write in mixed fraction always. 10 2 by 7 days. So more than 10 days. Less than 11 days there is. So 10 2 by 7 days. They can two together they can complete. So if you know 1 day's capability, how many days means just reciprocal of this number. Right? These are the statements you can follow. Just we know starting. You remember this three statements. Number of days to do certain work is 1 by 1 day's work. Anything that means reciprocal of that number. Right. So these are the mostly you can expect the similar type of problems, the time and work, like together from there some dust is removed. So such type of problems you can expect same. You can do similarly, right? And the watching the first time, right? You can see the links in description below about the chapter wise, subject wise material, and you can subscribe to our channel to go through the content or series in order to learn.